Q&A. Hello and welcome back from the short break. I'm here with Johnny Hooyberghs. Is that correct? Thank you. And he's here to teach us all about the new features in .NET 6. And I can see that you have a lot of experience with .NET over the years, a lot of Microsoft experience. So I have very high hopes for this talk, and that have a deeper knowledge of .NET when we're done. So are you ready to go, Johnny?
I am fully ready to go.
Thank you. Then the stage is yours. Just start presenting, and we will have a little Q&A section at the end, which I'll be moderating. So please, attendees, fire your questions in the chat or the Q&A tab, and I will pick them up at the end.
All right. Perfect. Thanks for the introduction, Andreas. And yeah, indeed. So my name is Johnny Hooyberghs, and I'm going to talk about what is new in .NET 6, but also a little bit about the new C# 10. And because we're already halfway through version 6 and version 7 will be coming this year, I will also give you a little look into what maybe is new for .NET 7 and C# 11. As Andreas already told you, my name is Johnny Hooyberghs. I've been doing .NET development for quite some time now, actually since the early beginnings of .NET, as a hobby first and then professionally since 2008. I am a passionate developer. I like developing things specifically in .NET, but I'm also a principal software consultant and architect for a Belgian company called Involved. I'm also an operational manager at Involved, which gives me a very cool and flexible job where I can really have fun, work with technology, work with my colleagues and very nice people at my company, but also do these talks for people like you attending these kinds of conferences. I've also been a Microsoft MVP since 2020, so which also gives me even more information about what's upcoming and what is new in .NET. So throughout this session, if you have any questions, you can ask me. You can ask during the Q&A, but you can also contact me afterwards using my Twitter handle or my professional email address, or on LinkedIn. And if you look very carefully, you can see in the bottom of each slide there is a little link. And that link points to my GitHub page. And my GitHub page has a couple of repositories, but specifically for today, I have the repository for the Dev Days Europe 2022, what is new in .NET 6. It contains all of the examples. They are already there. It also contains my presentation slides. So if you're already tired of my voice, you can just leave and you can look at everything that's already online. But of course, I would really like you to stay, and then afterwards you can go ahead and download this repository and see it on your own speed. So let's go back to the slides. So before I show you some new features, I'm going to very quickly talk about the history and the future of .NET. As I said, I've been doing .NET since its early beginnings in 2002 and then onwards. And actually, first, there was the .NET Framework. Microsoft created the .NET Framework as an SDK and a base class library, but also a runtime, where we could create Windows and Microsoft applications quite easily. Throughout the years, the .NET Framework became bigger and bigger and bigger, but also better, of course. But it was not really platform independent, and it actually grew a little bit too big for its own good. The .NET Framework still exists today. The latest version is the 4.8 version, which came out in 2019, but it will be the last version that Microsoft puts out there. It is still supported, but there will be never a new version of the .NET Framework. So this is actually the history of the .NET Framework. The .NET Framework was the first one. It's a very good one, but it is finite. It stays with version 4.8. So what happened then? Well, basically, Microsoft created a completely new framework, which they called .NET Core, which is kind of the same thing, but they started from scratch. And because they started from scratch, they could do some things better. They could really create a platform-independent .NET framework, which actually runs on multiple hardware architectures, but it also runs on multiple operating systems like Windows, but also Linux and also Mac, and even mobile devices. So in 2016, they introduced the first version of .NET Core, which was still small and very young. And then multiple times each year, they got newer versions out. And of course, in that time, we had two versions of the .NET platform next to each other. We had the older .NET Framework, and then we had the newer .NET Core. The idea was the same thing, but .NET Core was more performant, really platform independent, and it was actually the future for us developers today that are doing .NET and C# development. It's the real cloud native version of the .NET framework, where we can create cloud applications. We don't really care about what architectures or what operating systems we need to use. It should just work, which is great. So what is the future of .NET? Well, basically the future of .NET is where Microsoft kind of abandons the .NET framework, not really abandons, they're just not creating new versions of it, but the latest versions of the .NET framework are still supported. So if you have legacy applications, you can still you are still supported. There are still security fixes, there are still bug fixes for you, but there will be no new features. But in the future, there will only be the .NET, which is actually the newest version of the .NET Core. So there's actually three names to remember here. There's .NET Framework, there's .NET Core, and there's just .NET, where just .NET is the new .NET based on .NET Core, and this is the one going forward. In 2020, we had the first version, which was version 5, the first version of this new .NET platform. And then last year, we had .NET 6. That's the one that I'm going to talk about today. And then this year, in November, we will get a new version, which is .NET 7. And each year, we will have a new major release of .NET. And each 2 years, we will have a major release that is also a long-term support release, which means that these long-term support versions of .NET will be supported for 3 years. So if you are using .NET 6 today, which is a long-term support version, then it will be supported through 3 years from its release last year in November. The in-between releases like .NET 7 this year and then .NET 9 in 2 years, they are not long-term support versions, so they will only be supported for 18 months in between these LTS versions. And yeah, that's basically it. I'm very happy that Microsoft decided to go this route, which means abandon the .NET framework and go for .NET all the way, platform independence all the way. .NET is much more performant than .NET Framework ever was. It's smaller in size to install the SDK. It's smaller in size to install the runtime. It's just a better experience for everyone, user and developer. So with that, I can go ahead and talk about some of these new features in .NET 6, but also .NET 7. I will start with the performance. Because Microsoft decided to start rewriting .NET from scratch with .NET Core 1.0 in 2016, they had the opportunity to really build everything from the ground up and work with performance in mind. So everything has better performance. The runtime, the thing that you need to install in order to make your .NET applications runnable on your machine, has been built from the ground up. It is more performant. It has better memory management. It has a better just-in-time compiler that compiles the intermediate language down into machine code, and that machine code will be better optimized. It also supports ahead-of-time compilation, where you as a developer, while publishing your applications, can fully or partly compile your application ahead of time, where you don't actually need the just-in-time compiler, which makes the startup of your application a lot faster. There's cool features like tiered compilation, where the just-in-time compiler will actually compile your code in multiple tiers. When startup needs to be very quickly, the just-in-time compiler will compile your code very quickly without doing any optimizations. But when your application is running and a user is using a feature multiple times over and over and over again, the just-in-time compiler and the runtime, they can work together and they can be really smart about this. If they see that a specific part of your code is being run multiple times, it can be optimized so that it runs even faster. And this is what the tiered compilation is. There's stuff like platform intrinsics, where you can actually write .NET and C# code that calls into your CPU's instructions directly. So there's no more extraction layer abstraction layer on top, you can immediately call your CPU to really leverage those very powerful features with platform intrinsics, depending on the platform, of course, and depending on the processor architectures. There's source generations, where you can generate source that can also be ahead of time compiled to even better your performance of your application. So there's so many options here to really create these very fast and very performant applications. Now, to show you some examples, with .NET Core, but now also .NET 5 and .NET 6 and .NET 7, Microsoft really got into the single SDK experience. And instead of just reading slides, I'm going to show you. So there's different kinds of templates that we can use to create different kinds of applications. But for .NET 6, everything looks the same. You have the project file, and now in Visual Studio, you can immediately open that project file by double-clicking it. Previously in the .NET Framework, this was not possible. You needed to unload your project, and then you needed to load the XML file that was your project file. But now you can just double-click in Visual Studio, and it will open your project file. And you can see that it's also a lot simpler than it was before in the .NET Framework. There's only a couple of parameters here, because by default, we're just using the default values for everything. If you want to override those default values, you can add them here from documentation, and you can make changes to them. But something that's already very seeable is the fact that the target framework is .NET 6. So it's very easy. We just specify this project uses .NET 6. If I want to use another .NET version, the only thing I need to change is this. If I want to go back to .NET 5, I just change to .NET 6 to .NET 5. And that's everything that I need to do. If I open my dependencies for this project and my frameworks, you can see that it uses a Microsoft Net Core app package. It's some kind of a virtual package that just describes which version of .NET you are using. And if you look at the properties, you can see that we are using indeed version 5. Again, when I change it to 6 and I save my project file, I go back and I look at the properties for this package. Now we're using 6.03, which is the latest SDK version for .NET 6, which is cool. It works very easy. I don't need to do it from Visual Studio. I can just do it command line and Notepad if I want, by just changing those properties, and the .NET SDK just works. And this makes the SDK experience very flexible. I can do the same thing on a Linux machine. I can do the same thing on a Mac OS device. Again, you don't need Visual Studio to do this. It's all part of that unified SDK. Now, creating this .NET 6 application like this is really a platform-independent application. I can compile it, run it on Windows. I can compile it and run it on Linux. I can compile it and run it on other operating systems. Now, of course, sometimes I really want to create Windows-specific applications. So in that way, you can actually add an additional -Windows to your target framework. And now you are actually specifying to the SDK, please allow me to also use additional features that are only available on Windows. And again, the only thing you need to do is just add the -Windows here. And if you look at the dependencies and the frameworks, you can see that there's an additional package being installed. In this case, the Microsoft Windows Desktop.app.Windows Forms package. Again, it's a virtual package that just allows you to use a little bit more of that base class library and framework class library that's in .NET that is very specific to Windows. Now you get an additional set of namespaces and classes you can use just by specifying the -Windows, but of course also specifying that you are going to use Windows Forms. If you rather use WPF instead of Windows Forms, it also works in the same way. You also do the -Windows because you want to target Windows specifically, and then you add the use WPF. The only difference here is that in the dependencies, you're using the Windows Desktop app.wpf feature instead of the one for WinForms. And again, you don't need Visual Studio to make this work. You can just do it via the .NET command line interface and your text editor of choice. It will all automatically be prepared for you by the .NET SDK. Very cool. Now we can even go one step further. If I want to use very specific Windows version stuff, I can even add the version of Windows that I want to target. Why would I do that? Well, basically, there's even more APIs that we can use that are very specific to Windows 10 or Windows 11 SDKs. And if I want to use those, I can just add the version number of that Windows SDK, and I can now use namespaces from that. So in this example, I actually created a WinForms application, very simple WinForms application, where I have a button, and if I click that button, my webcam will create a picture of me. So I'm just going to run it, not going to wait for the designer to load. Hopefully it will compile quickly. There we go. So this is a very simple WinForms application. It will only work on Windows, of course, because I added the dash Windows. But to take pictures from your webcam, there is an API available in the Windows 10 SDK. And if I want to use that, I just add that version number. And now I can click take pictures, and you can see me and a little bit behind the screen of my very crappy green screen in the back here. This, when I show you the code, actually is very simple to do. I'm using namespaces Windows Media Capture and Windows Media Properties and Windows Storage. And these namespaces are not part of the base class library or the framework class library. No, they're part of that Windows 10 SDK. And I can just use classes from these namespaces because I specified in my project file that I want to target that specific version of Windows. If I remove that version and I make a save and I go back to my form, and I have a little bit of patience. There you go. The namespaces are now not recognized. I cannot find them. The type or namespace Windows could not be found, and then those classes cannot be found because now I'm not targeting that very specific version of Windows, which is very powerful. You as a developer have the option to specify, do you really want to go all the way platform independent? Do you want to go Windows specifically, or do you want to go a specific SDK for Windows specifically? So very powerful features here. And then, of course, we have things like web applications, ASP.NET, which we already had in .NET Framework, but we also have MAUI, or the multi-application user interface, the multi-platform application user interface library. And with this, we can even go a step further. I can target .NET 6, not for Windows, for example, but for Android, and .NET 6 for iOS, and .NET 6 for Mac Catalyst. So didn't yet talk about this, but you can even combine these target frameworks. So you can compile your application for multiple target frameworks at the same time and create multiple binaries with that if you want to create platform-independent application. So with MAUI, which is still in preview, but it will come out a little bit later this year, and then it will also be more integrated with .NET 7 in November, you can create mobile applications for Android, iOS, Mac, and so on. So yeah, that's it for this part. Let's see in my slides, what did I miss? Of course, the single SDK experience also has that hot reload feature. We had some discussions about that a couple of months ago, but if you can just command line .NET Watch, which gives you a hot reload feature where you can make changes to your code and your application will automatically include those changes while it's running, so you can immediately see what is happening, which is a very powerful feature. And of course, there's also support for Azure Function apps, and on Azure, you can select the latest .NET SDK and runtime versions for you to use. Okay, second thing that I want to show you is a couple of deployment features. If you're not really familiar with these, maybe you find them very interesting. The first thing with a .NET Core and a .NET 5 and 6 and 7 application that you need to know, which is a lot different from the .NET Framework, is the default executables. If I go to the bin debug folder, you can see that this is a console application, and it actually generates an executable and a DLL file at the same time. Very important to know that your .NET code is actually inside of the DLL and not inside of the executable. So your .NET intermediate language and compiled assembly is the DLL, and the executable is the default executable that's being created by the SDK for the platform that you are running on. So we are developing on a Windows machine, or at least I am. So it's generating the executable automatically. And the executable is just a native executable that is a bootstrapper or a wrapper that will start up the runtime, and then the runtime will load in this DLL. So there's always these two. So if you are building a console application or a WinForms or a WPF application, don't forget to also include that DLL with the same name, because that actually is your .NET assembly containing all of your .NET code, and the executable is just the bootstrapper to make it work. If you do the same thing on Linux, you will of course get the Linux kind of executable next to the same kind of DLL. So the DLL is the same because it's platform independent, but yet the executable is native to the platform you are developing for or developing on. Very important to know. There's also publish single file, which is actually an SDK option you can add. Publish a single file for a very specific runtime identifier, which actually publishes one single executable that has everything contained inside. I hope I prepared and I don't have to publish over once more. I can't find the open folder. There we are. So bin, maybe release, .NET 6. Is this the one? Nope, this is the one. Yeah. So with publish single file, you can actually help your users if you create a very simple application and don't make them afraid of the loads of files that you are creating. If you have a large project which has a large solution with many projects, or you're using lots of dependencies, it's a lot of files. And actually you can, by specifying a runtime identifier, compile for a very specific platform. And in that case, you don't even need the runtime installed. You can just put all of these files in one folder, and you can run your self-contained application from that. So you don't need the runtime installed, because the entire runtime is part of all of these files that are being created for you. So you can just put this on a zip drive or a USB stick. Are we still using those? And you can give them to your friend, and he can run your application without any prerequisites needed. But of course, it's a little bit scary. If you give this to your grandmother to tell her I love you in a console application or something, she's going to be very suspicious, because it's a lot of files. It's a large file size, and that's why the publish to a single file executable is maybe a little bit more user friendly. Now, this file contains everything that is needed to run a .NET application. It contains the entire runtime, the just-in-time compiler. Everything is inside of the single executable. You can just put it on a USB stick, give it to your friend, and it will work out of the box, which is a very powerful feature. If your friend is smart enough, he will see it's quite large for what you are maybe trying to do. And for that, there's even an additional thing that you can add, and that's the assembly linking. I'm not going to show you because I don't have a lot of time, but with the assembly linking, you can basically make the compiler be smart and throw away all of the dependencies that you're not using, really throwing away parts of the base class library, the framework class library, and all of the dependencies that you've added that you are not actively using, which will make the file size a little bit smaller. I think it's going to be around 20 megabytes in the case of a console application, instead of the 60 that I showed you before, which looks a little bit nicer. Of course, be very careful with this, because it's the compiler that is going to throw away the things that you're not using. So if you're dynamically using parts of the dependencies by using reflection, for example, the compiler will not know that you're using them, and he will throw them away, and your application will have runtime issues with that. But it is an option for you to use by just adding the publish trimmed SDK command to your project. All right, what's next? Of course, we have some modernized templates. So when in .NET 6, but also in .NET 7, you are creating new projects. Let me find the correct Visual Studio here. This one. When you create new projects, you will see that they look a little bit different. If you, for example, open the console, you can see that there's no more usings, there's no more namespaces, there are no more classes. There's even not a main method. It's just code. And this code is like a scripting language or something. No, it's just C#, but everything is stripped out. That is always the same thing. For me, sometimes I think it's good, and sometimes I really miss the namespace and the class and the main method. So it depends on the use case. But there is an option in Visual Studio to turn it back on, so that if you like the namespace and the main method and the class program class, you can add them, or you can add them manually. Basically, it's a compiler feature. It's not a .NET feature. The C# compiler, when compiling this, will automatically add all of those things for you. So if you look at ILSpy, for example, and in the modernized templates, you really look at the source code that's being generated, and I decompile it again from the intermediate language. You can actually see that there's a static class program being generated for me, and there's a main method being generated for me. So it's just a compiler feature. But it is cool if you like your code to be very concise. And in this case, it's very concise. And actually, it's for all of these different templates in .NET. There's the console application, there's the ASP.NET empty web application, which also only has that program.cs. No startup classes or no program classes, no namespaces, just everything that you need to have a very simple web API in this case. This is actually using the minimal API, where I just need a web application builder. I set some environment parameters, and then I can immediately, instead of using controllers, map for the root endpoint to return the string hello world, and then for the person endpoint to return a new instance of a person object. So again, very concise in code. It has its positive sides, but of course, when you have a very complex application with hundreds of endpoints, you probably want to do it in a different way, so that you don't have one large C# file, but then you want to use classes to separate all of the logical things into their logical classes. Of course, when you're new to .NET Core and .NET in itself, there's new kinds of templates also. There's stuff that really doesn't make sense in a platform-independent world. In the past, we were creating Windows services. Well, a Windows service does not make sense on a Linux device, for example. So in that way, we now have something which is called a worker service. And a worker service is just a console application that uses a host builder to register classes that run as a worker. And these worker classes are about the same thing as what you would do in a Windows service in the past. It's just a long-running process that does something in the background by just using an infinite while loop that looks at a cancellation token. And when the cancellation token is cancelled, your long-running process will stop eventually. This is actually a very cool template, because you can build this into a Windows service, but you can also build it into a Linux daemon to do the same thing on a Linux machine, like a long-running, behind-the-scenes Linux daemon. Very cool, very flexible for us to use. Something else that went away with .NET Framework is WCF. So when you want to create these web services with WCF, well, that's not an option anymore in .NET Core and .NET. So they have a replacement for that, which is called gRPC, to do remote procedure calls. Very cool. Also, this is completely platform independent, so we don't have WCF, we have gRPC, and you can run this on whatever device and whatever platform that you need it to run on. So what's next? All right, maybe to end my presentation, let's just dive into the base class library for .NET 6 and a little bit C# 10, which is the newest version of C# and C# 11, and show you all of the new features there. I probably won't have enough time to do the rest of the presentation, but again, you can download the slides from my GitHub page, and you can see all of the examples on my GitHub page. So let's go to the .NET BCL and C# 10. Somewhere. It's going to be here. So what should I do first? Yeah, one very simple feature that I actually like and I never thought about is the file scope namespaces. So if you define a new C# file, and within that file there's a class or whatever, or an interface or an enumerator, it always has a namespace, and that namespace always uses curly braces, just like this. Now, never really thought about that, but it's a bit weird because most of the time I'm only using one namespace in a single file. You can have multiple namespaces in a single file. I can do a second namespace within the same file. It is possible. I never knew actually that it was possible, so I never used it. If you only use one namespace, why do you need to curly braces? We can just leave the curly braces, put a semicolon in the end of the namespace, and now all my code gets indented to the left, which gives me a lot of more screen estate to do my code in. So this is, for me, a very simple but a very powerful feature. Of course, when you're still doing multiple namespaces, you need the curly braces to define where your namespace starts and where your namespace ends. But in most cases, I don't think many developers do this. So you can always just use the file scoped namespaces. Very cool feature. There's something called global usings, which I actually use today very often, where you have a program class, for example, just a top-level program. There's no namespace, no classes, no methods. And then there's my person class. And if you look at this carefully, you can see that I'm using things like Faker, which is a class from a NuGet package that I'm using, faker.net. But there's no using in the top here. This is my person class, which is defined in the namespace global usings. If I go to my program class, I can see I can use my person, but there's no using in the top. I can do write line from the console, but I'm not using the console class. I can just do write line, and I'm using t.delay. What the hell is t? Well, t is actually a shorthand for task. So what is happening here? Well, you can have a separate file or multiple separate files in your project where you put usings that you're actually using throughout of your application to clean up your code a little bit. So I'm actually using my own namespace global usings for all of my files. I'm using bogus from that faker.net NuGet package. I'm using static system.console, so I don't need to type console everywhere. I can just do all of the methods that are static on the console class. And I'm creating an alias t for the system.threading.tasks.task class. And I just put this in a single file, and all of these usings will now be available throughout my whole project automatically. So if you have like a million source files, that the first complete page in Visual Studio is just usings, and it's always the same usings, you can put them in a separate file and it will clean up your project thoroughly. Very nice. There's also implicit usings. So from .NET 6 onwards, and C# 10 onwards, there's implicit usings where a lot of things like system and system.io, system.task.threading, systems.collections, all of those namespaces are implicit. The C# compiler will just add them everywhere for you, so you don't need to do it yourself. So I can use a dictionary, I can use a task, I can use file info without adding all of the usings. I don't even need the global usings. It will be added for me automatically. If you're very weird about it, you can even completely customize it in your project settings. So in your project settings, you can add these global usings by telling, okay, disable the implicit usings. So I don't want C# to add implicit usings for me, but I want to have my own custom ones where I include system everywhere, system.console everywhere as a static, and then the E alias for the system.environment everywhere. So you can mix and match between all of these different features. Now, what shall I do next? There's a couple of very small things, like date only and time only. These are completely new classes in the .NET base class library. Instead of doing date time, you can now do date only or time only when you only need the date part or the time part. So no more fiddling around with date times that have 0 as time or 0 as date. Very cool features. Of course, you can create a date only from a date time or from a day number or from a constructor that has the year, month, and day, stuff like that. So you have multiple options available for you. What do we have next? This is also a fun one, the priority queue. So also a new class in the systems.collections.generic namespace where you have a queue that you can give an additional priority. So I can enqueue items and dequeue items from the queue with a priority, where you can have items. It's not really a first in, first out queue then, because we have priorities. But if something has the same priority, then it will be first in, first out, and otherwise it will be ordered given by that priority. And that priority is a generic type. So whatever is can be ordered or is sortable, you can use. So you can have your own custom class as a priority, as long as your custom class implements the interface iComparable, so that you can compare items to each other, and then the queue will actually figure out what the order is. Something that I'm actually also using is the periodic timer, which is also a new class in the base class library in .NET 6. It's a different kind of timer that doesn't work with a callback function like an interval event or something. No, this works with the await, async await stuff. So your timer can now run in a while loop where you await for the next tick to occur. So if you have a 1 second or a 10-second delay, you can just await for the next tick and then do something within a while loop, which I think is a very cool feature if you don't really like those callback functions in your timers. What else? Yeah, of course, records were something new in .NET 5, but then in .NET 6 they added some stuff to that. Records are actually kinds of classes that are immutable by design. So if I create a record person, it has two properties, a name and an age, and those properties don't have setters. They only have initializers, which mean that those properties can only be initialized. And once you initialize the object by using the constructor or the object initializer, those properties cannot change anymore. So it's a real immutable object. There's even a shorthand to create a record like this by just adding the properties as kind of the constructor syntax, and then those will automatically be added as properties, but also as a constructor. And how do you use it? Well, just like you use a class, you use the object initializer, or you use a constructor if you want. Now, because those objects are immutable, you can easily copy them to other objects. And you can copy them with the with keyword. So I can say I create a person 3, which is the person 2, which already exists. And I take a copy of that with the age now equal to 25. Because beforehand, the age was 36. So you can create copies of objects while changing properties in doing so. So very cool feature. Now, what is new in .NET 6 is that there's also record structs. And why? Because actually the record in .NET does not exist. It's a C# feature. There is no records in .NET. There's only records in C#. And when you compile this and you decompile it back into an older version of C#, it will actually be a class, just a class. But there will be some source code generated for you to do the comparisons and to make sure that you cannot change any properties when you initialize them beforehand. Now, because this is the default record is a class, some people really needed it to be able to being a struct also. And that's why now you have the option to create a public record struct instead of a public record by default, which is a class. So that's completely new. Just to make things a little bit weird, a record struct is not immutable by default. If you want to make it immutable by default, you need to add the read-only keyword. It's a little bit confusing, but it's the way it is, because how a struct should work. Now, what can I talk about next? There's a couple of C#11 features that I also snuck in here, because in 6 months there will be .NET 7 and C#11. So there's generic attributes, where beforehand you could have an attribute, a custom attribute that you designed, and if you needed something with a type, you needed to use the type class in order to do that. But with C#11, we have finally support for generic attributes, where you can have an attribute of type Boolean to do whatever you want with that, with reflection or whatever you need your attributes for. but finally we have generic attributes for our attributes, or generics for our attributes. Other things like new lines in string interpolation, which is a little bit of a crazy feature. This is string interpolation, where you can have within those curly braces a variable that will be interpolated within your string. But now you can have multi-line within that if you want to do some complex logic. So in this case, this is my string, and it continues in the end, multiple lines down. And then in between, this is my interpolation, where it's not just a simple variable. No, it's a variable where I want to do a switch on. And then in case the wind direction is north, I want to output north and interpolate that into my string. And otherwise, it's going to be east, south, or west. Very cool feature. Now you can have more complex logic within your string interpolation. And then finally, there is raw string literals. So we all know that we can have strings, and strings are delimited by these quotes. Now, if you add triple quotes to your code, you can have whatever you want inside. You can have multi-line. So this actually is one single string, but now I can put it on multiple lines. So if I run this, you will see that this is going to be a block of text inside of a console application, which is very cool if you are patient. There we go. Now, what you can
was that a Rickroll?
Yes, it was. Very good.
I think I saw it. You have to wrap up soon. We have 3 minutes.
Yeah. This is the final thing that I want to talk about.
Great.
So yeah, then the thing that this is very powerful for is actually JSON. If you want to do JSON, and you actually also want to do the curly braces, you can have the double string interpolation sign. And because we do double string interpolation sign before our triple quotes, in order to do string interpolation, we need to do double curly braces. And because we need to do double curly braces, we can use the single curly braces as literals. So now I can just type a complete JSON structure and have this as my string object. And I can just read it more easily than when I need to put it on a single line, for example. And it has the curly braces, it has everything that you expect, it has the quotes inside, and it just works. And with that, yeah, I only have a couple of minutes left, so I'm just going to go to my final slide. I told you I have 3 hours of content here. There's so much that I want to talk about, but I don't have, unfortunately, don't have time. But all of the information is on my GitHub. If there are any questions, I would be happy to answer them for you. You can contact me in different ways. There's the QR code if you want to scan and be guided directly through my GitHub page. So yeah, are there any questions?
Actually, I think we got one question. Let's see. It's from Alerisa. Sorry if I pronounced that wrong. Are there any plans C#.NET certifications like exam 70-403 programming in C# has been ratified?
I've indeed heard this question a couple of times, also from the MVP audience itself towards Microsoft, but we didn't yet get any answers on that. So I can't answer that question, unfortunately. So yes, indeed, in the past we had certifications for C# and .NET, but today the certifications are mostly targeted to cloud and Azure and stuff like that. So no, unfortunately, I cannot answer your question. I'm very sorry.
Too bad. So no more questions. Let me just check the chat as well. No, nothing new. Thank you, Johnny, for a lovely presentation. A lot of good stuff coming up in .NET, I can tell.
Yeah, and the thing is, because every year there's going to be a new version of .NET and a new version of C#, which means that every year there's going to be loads of new features, which is making my job a lot harder to fit everything inside of a 45-minute conversation, of course.
That's good. Oh, we got one more question. Quick question. Do all these global usings and implicit usings affect my app's performance in any way?
No. Because it's purely a C# and compiler feature, which means that basically the compiler adds them everywhere, but then the compiler works in different tiers, in different steps. So in the first step, he will just add it to all of your files, and then the actual compilation will start, and there it will be optimized. And C# knows that if you are adding usings that you're actually not using, they will be optimized out, so they will be removed again. So in the actual compiled intermediate language code, they don't have any impact.
So there's no performance penalty in just having these.
No.
Oh,
Yeah,
I'm gonna implement some of them today.
the performance penalty will be when compiling your code, but it will be minimal because it's just adding some text and removing some text from source files. But when it's actually compiled during runtime, there's actually no difference at all.
Cool. Awesome talk. Thank you very much for your time.
Very happy to be here, and enjoy the rest of your conference.
Thank you. For the rest of you, we will have an hour lunch break, and we will be back at 13. Sorry, in an hour, which is like, I think it's 12:40 GMT +3. So have a nice lunch break, and I'll see you guys in about an hour. Thank you very much again, Johnny. I hope I'll see you again sometimes soon.
Yes, hope so too. Bye-bye.
Bye.